In this unit, we'll learn how to solve linear equations. Let's begin by defining a few terms. An equation is a mathematical sentence that contains an equal sign. A solution of an equation is a value for the variable that makes the equation true. And to solve an equation means to find all the solutions. Mathematicians often write solutions in set notation, and set notation is when you write your solution within braces. You'll see this done later in the video. The process of solving linear equations. To do this, you must use the addition and multiplication properties of equality to write equivalent equations until your variable is isolated. Let's first talk about the addition property. If you have an equation where, let's say, A equals B, this is equivalent to the equation A plus C equals B plus C. In other words, the same number can be added or subtracted on both sides of an equation without changing the solution set. Similarly, the multiplication property of equality says that if you have an equation A equals B, you can multiply both sides of the equation with some value, as long as the value is not 0. And that also means that the solution set will not change. And so we can use this property of multiplying or dividing or adding or subtracting on both sides of the equation to solve our linear equations. Let's do a few examples. For the equation x plus 17 equals 8, we want to get that x variable all by itself. We often call this isolating the variable. So in order to do that, we want to subtract 17 on both sides of the equation. That doesn't change our solution sets. Then we carry down our variable x. Our 17 minus 17 cancel out, and 8 minus 17 is negative 9. So our solution is negative 9. For example 2, we want to get y by itself. So we would do the inverse of subtracting 2.5, so we'll add 2.5 to both sides of the equation. Now, y is by itself again, and our negative 2.5 and positive 2.5 cancel out, and we get 4.1. So our solution is 4.1. For example 3, the operation that's happening is multiplication. So we have negative 3 times a equals 24. If we want to isolate that variable a, we want to do the inverse operation of multiply by negative 3, which would be to divide by negative 3. So I'm going to divide the left side of the equation by negative 3, which means I also want to divide the right side of the equation by negative 3. And then I'll end up with a equals negative 28, which means that my solution is negative 8. For our last example, 3/4 n equals 9, we again want to isolate the variable. But isolating n by division would be a bit complicated since we have fractions. For example, dividing by 3/4 on both sides isn't what you want to do because dividing with fractions, it gets pretty complicated. So alternatively, if we want to isolate the n variable, in this case, we would want to multiply both sides of the equation by 4/3, the reciprocal of what 3/4 is. And when we do that, we can see that our 4's will cancel, our 3's will cancel, and we're left with just n. So n is now going to equal 9 over 1 times 4 over 3, and let's multiply that together. 3 times 4 equals 12. So 12 over 1, which is 12, which means that our solution is 12. Try these 4 examples on your own by pausing the video, completing and solving the equations, and then you can resume the video to check your answers. Okay, let's quickly check our answers. To solve number 1, we should subtract 12 on both sides to isolate our variable. So x is going to equal negative 19, and negative 19 will be our solution. For number 2, to isolate y, we want to do the inverse of subtract 2/3, which means we'd want to add 2/3 to both sides of the equation. Now, since we're dealing with fractions, we'll need to get common denominators. So, negative 5/6 will get added with positive 4/6, because we'd want to multiply this fraction by 2/2 to get a common denominator. When we combine these two fractions now, we'll get negative 1/6. So negative 1/6 is our solution. In example 3, you can see our variable is written on the opposite side of the equation. It's on the right side of our equation, but that doesn't change our steps. We still want to isolate the variable. This time we want to do the inverse operation of multiplication, which will be division. So a equals 5, and 5 is our solution. And lastly, we have another fraction. So to isolate n for number 4, we'd want to multiply by the reciprocal. So n is going to equal, well, 10/1 times 8/5. We can cancel and reduce our fractions. 16/1, just 16, and therefore 16 is our solution.